Humanity has always looked to the stars, but how far can we actually go? For centuries, we've dreamed of traveling beyond Earth, beyond the Moon, and even beyond our solar system. But are we anywhere close to making that a reality? Right now, we're taking our first steps with missions to the Moon, plans for Mars, and the hope of building a future beyond our home planet. But the universe is vast, and the distances between stars are so extreme that even the fastest spacecraft would take thousands of years to reach the closest one. So, what's the future of space travel? Will we ever set foot on another planet? Could we reach another star? And is faster than light travel even possible? Before we can talk about traveling across the galaxy, we need to look at where we stand today. Right now, humanity is still in the early stages of space exploration. The farthest any human has traveled is the Moon, with the last Apollo mission in 1972. Since then, our focus has shifted to robotic exploration and the International Space Station, which orbits just 250 miles above Earth. But the next big step is already in motion. Space agencies like NASA, ESA, and private companies like SpaceX are planning crewed missions to Mars, with hopes of building the first human colony on another planet. If successful, this would be the first real step toward becoming an interplanetary species. However, Mars is still within our own solar system. If we want to go beyond, to explore distant exoplanets or even another star, we'll need to completely rethink how we travel through space. That's where the future of space travel comes in. Could we really set foot on another planet beyond Mars? Could we reach another star? To do that, we need new propulsion technologies, ones that could take us beyond the limits of rockets and chemical fuel. For the first time in history, humans are preparing to leave Earth for another planet. The Moon was just the beginning, but now all eyes are on Mars, the next major step in space exploration. NASA and private companies like SpaceX are developing spacecraft that could take humans to Mars within the next 2 decades. The goal? To establish the first permanent human colony on another world. But landing on Mars is just one part of the challenge. The planet's thin atmosphere, freezing temperatures, and lack of liquid water make survival incredibly difficult. Any long-term mission would require advanced habitats, artificial ecosystems, and a way to generate oxygen and fuel from the planet itself. But Mars isn't the final destination. If we can establish a colony there, it opens the door to even bigger possibilities, missions to the outer planets, their moons, and even deep space exploration. Scientists have already proposed the idea of a human outpost on Titan, one of Saturn's moons, where thick clouds and liquid methane lakes create an entirely alien environment. But even if we can conquer Mars and explore our solar system, we still face a much bigger challenge: interstellar travel. The nearest star system, Alpha Centauri, is over 25 trillion miles away. With today's technology, it would take over 75,000 years to get there. Clearly, rockets won't cut it. If we want to travel beyond our solar system, we need to rethink how we move through space. Reaching Mars is one thing, but what about traveling beyond our solar system? The distances between stars are almost incomprehensible. The closest star system, Alpha Centauri, is over 25 trillion miles away. With our current fastest spacecraft, it would take over 75,000 years to get there. This presents a major challenge. How do we cross such extreme distances in a reasonable time? The problem isn't just speed, but also fuel. Traditional rockets rely on chemical propulsion, which simply doesn't provide enough thrust for interstellar travel. Even nuclear propulsion, while more efficient, would still take hundreds or thousands of years to reach another star. Some scientists suggest using generation ships, massive spacecraft where multiple generations of humans would live and die during the journey. Others propose suspended animation or cryosleep, allowing travelers to survive a multi-century journey. But both of these ideas come with huge technical and ethical challenges. If we want to explore other star systems within a human lifetime, we need a completely new way of traveling through space. Could ion propulsion, solar sails, or even theoretical warp drives bring interstellar travel closer to reality? If we want to reach beyond our solar system, we need to go faster, much faster. Traditional rockets, powered by chemical fuel, are simply too slow. Even the most advanced spacecraft today would take tens of thousands of years to reach the nearest star. But new propulsion technologies could change everything. One of the most promising ideas is nuclear propulsion. Instead of burning chemical fuel, a nuclear thermal rocket heats liquid hydrogen using a nuclear reactor, creating a far more efficient and powerful thrust. Scientists estimate that nuclear rockets could cut the travel time to Mars in half and drastically improve deep space missions. Then there's ion propulsion, which doesn't rely on combustion at all. Instead, it uses electrically charged ions to generate thrust. While much weaker than traditional rockets, ion engines are far more efficient and can accelerate continuously for long periods, allowing spacecraft to reach incredible speeds over time. NASA's Dawn spacecraft successfully used ion propulsion to explore asteroids, proving that this technology works. Another fascinating concept is solar sails, thin, reflective sheets that harness light from the sun to push a spacecraft forward. Unlike rockets, solar sails don't require fuel, making them an ideal candidate for long-duration space travel. The Breakthrough Starshot initiative is already testing small, lightweight solar sails that could reach speeds of up to 20% the speed of light, potentially allowing a probe to reach Alpha Centauri in just 20 years. But even these technologies have limits. While they could get us to Mars faster or send probes to distant stars, they still can't break the ultimate speed barrier, the speed of light. If we ever want to truly explore the galaxy, we need to find a way to go even faster. Even with the most advanced propulsion systems, there's one problem we can't escape: the vast distances between stars. At our current speeds, reaching even the closest star system would take thousands of years. If we ever want to explore the galaxy, we need to go faster than light. But according to everything we know about physics, that should be impossible. Einstein's theory of relativity tells us that as an object approaches the speed of light, its mass increases exponentially, requiring more and more energy to accelerate. To reach light speed, you'd need infinite energy, something no known technology could ever provide. But what if there's a way around this limitation? One of the most intriguing ideas is the Alcubierre warp drive, first proposed in 1994 by physicist Miguel Alcubierre. Instead of moving a spacecraft through space, a warp drive would bend space itself, compressing space in front of the ship and expanding it behind, effectively moving space-time rather than the ship itself. This would allow a spacecraft to travel faster than light without breaking the laws of physics. The problem? It requires exotic matter with negative energy, something we've never observed or created. Without it, the warp drive remains purely theoretical. Another possibility is wormholes, theoretical tunnels in space-time that could create shortcuts across the universe. If they exist, they could allow near instantaneous travel between two distant points. But just like the warp drive, wormholes face huge scientific challenges, including instability and the need for exotic matter to keep them open. For now, faster-than-light travel remains in the realm of science fiction. But physics is still evolving, and what seems impossible today could one day become reality. Will we ever find a way to travel faster than light, or will the universe's speed limit keep us forever bound to our cosmic neighborhood? Space travel has come a long way, but the universe is vast, and the challenges ahead are immense. Mars may be our next destination, but reaching other stars is still far beyond our grasp. New propulsion technologies could take us farther than ever before, but unless we find a way to break the speed limit of light, interstellar travel will remain just a dream. Yet, history has shown that what once seemed impossible can become reality. Could we one day develop the technology to reach the stars, or will the laws of physics keep us forever bound to our cosmic neighborhood? What do you think? Will humanity ever travel beyond our solar system? Join us next time as we explore more mysteries of the universe.